So, welcome to Learning Beyond, all of you. I'm Anil Mahadik. Today we are going to discuss on structural drawing study. So, all of you know that whenever the construction is done on the site by the contractors, they refer the structural drawings and architectural drawings. So, as a part of structural engineering, we are going to discuss on the structural drawings from today. So, we are going to conduct a series of sessions in this program. And to start with, let me share my screen. Yes. So yeah, as I discussed, we will start with the structural drawing study. And you might have seen on different projects, generally structural engineers are sending the drawings like this. This is a structural standard drawing actually. So the structural engineer is giving, say, design of footings, design of beams, then design of columns like that. And they will give you the drawings also accordingly. And whenever they give the schedule of the beams and slabs, they give this kind of structural drawings, which are standard drawings actually. So they follow the standard drawings and the schedule of beams, and they do the reinforcement detailing on the site. So to understand such kind of drawings, I will just give you example of this, that if you see this, then there are, say, slab details, then beam details, which are continuous beams, simply supported beams and fixed beams. Then there are stirrups also, shear reinforcement we can say. And there are cantilever beams also, continuous beams also. So different kinds of details are there for beams and slabs. And there may be staircase details also given, which are standard. Now, to understand such kind of drawings, we will start with the one simpler example, that is the simply supported beam. And during our series of sessions, I will give you the basic concepts regarding the detailing also. And then at the end, we will also discuss on these structural drawings, which is a practical structural drawings, we can say. So to start with, let me share my screen. So as a part of this program, to start with, we will start with the simply supported beam detailing and slab detailing in this program. Then slowly we will switch over to different types like fixed beams, cantilever beams in upcoming sessions. To start with, let's start with the simply supported beam details. Yes. Now I will take one simple example. So all of you know that in buildings, we have different kind of beams. So one is the simply supported beam. Simply supported beams, we know that we generally draw in the analysis like this. So there are two supports which are hinge supports, we can say. As they are hinged, therefore we call it as a simply supported. This is a hinge support. See, in this training program, we are only going with the basic concepts and structural drawing detailings in detail, we can say. So I'm not going in design and analysis aspects in this. For that, you can refer our other videos and our courses also. So if you see this simply supported beam, then there is a span, let's say it is a L span. And due to this load on the beam or slab, we can say, there will be bending moment like this. Simply supported will have a zero moment at the ends and maximum moment at the midspan at the bottom. So we know that there is a tension at the bottom and compression at the top. So this is the overall analysis concept. And generally in buildings, if we support the beams on beams, we generally design them as a simply supported. For example, I will discuss this. Let's say this is a beam So this is a beam. And the beam is supported on the beam. So these are also beams. We can say this is a beam. See, beam can support on columns or beam can support on beams also. So let's say this is our beam and this is also our beam detail. Okay. And the span of this beam, let's say clear span between these faces is L. Now, as you understand from this analysis diagram that there will be tension at the bottom and maximum moment is at the center. So this is the zone where the moment is more and therefore we require more steel at the center at the bottom. So generally whenever we detail this and there is a zero moment at the supports. So on site what is done or how the structural drawings are prepared. So we design the steel at the bottom for Mmax and we will provide such kind of reinforcement. So this is a reinforcement at the bottom. And to optimize the steel quantity, we generally curtail the bars also. So this will be kind of curtailment, we can say. So we are providing maximum steel at the bottom. So this total steel, this bar, curtail bar plus this bar is our total AST for this Mmax. So we will calculate the AST depending on Mmax by analysis formula and all. So this will be the steel at the bottom. And see, so you know that there is a compression at the top of the beam, but we need to provide the steel at the top just to hold the stirrups. It is not designed steel, we can say. So these we call it as anchor bars to hold the stirrups. So I will call this as anchor bars to hold the stirrup. This will be minimum steel, we can say minimum steel. And this is your design steel, AST design as per formula. Now, in this also you will understand as we are having a zero moment at the supports, we will not provide any L over here. So keep in mind, if there is a fixed end moment, then and then we generally do the L. Otherwise, don't do L here. So for simply supported beams, we don't provide any L here. Yes, but at the bottom, you can provide L like this, as we are having moment at the bottoms. So if you can provide such kind of steel. L. So this is the general detailing for the reinforcement, we can say, for simply supported beam. Now, apart from this, in any beam, apart from bending moment, we also get the shear forces. So how we have a shear force diagram generally. We get the shear force diagram like this. Generally, shear force is maximum at the supports, and we have such kind of diagram. So Vmax or shear force maximum. So we generally design the stirrups for maximum shear force. The maximum shear force is near the support. So this is the maximum zone, we can say. You know that at the support, we have more reaction. So shear force is maximum at the support. And at the center, there is a shear force which is zero or the values are less. So V minimum, we can say, near the center. That's why whenever we design the stirrups, we get more steel at the supports, stirrups, and less at the midspan. So here, once you detail out as per the design, then you will get more steel here, closer spacing. More steel means closer spacing, like this. And at the midspan zone, we will have a loose spacing. Okay, so this will be your stirrup detailing. So you can see the spacing near the support is very close. Yes, so this will be the overall detailing for the simply supported beam. And as I said to you, This is the VUMAX stirrups designed for this VUMAX. Now we will see what will be the detailing for this. For example, then what is the, if you see the main steel here, the curtailment is done over here. So what is the distance of the curtailment? So this distance is 0.1 L till this. Similarly here, we have this 0.1 L. So this is the detailing for the reinforcement. Then what is the distance of this maximum stirrups? So we will provide stirrups from here to here, which is 2D. And D is nothing but depth of the beam. So this is the zone where we will provide them closer spacing of the stirrups. So this is D. Similarly here on the right side also. And then there will be L. So how much should be the L length? So this generally we measure from the internal face till this height. So this is nothing but LD, which is development length. So in upcoming sessions in the standard drawing, I will tell you what is the development length for the reinforcement. It depends on the grade of steel, grade of concrete, and diameter of the bar. So this will be the LD for this. So this is the standard detailing of simply supported beam. We will see the structural drawings also, practical structural drawings. Now in the upcoming session, we will start with the fixed beam details, and subsequently we will go with the continuous beams and all. So till then, thank you all for attending my session. Let's meet in the next session. So thank you.